Welcome to a lesson with Dr. Powell. Let's take a look at symmetries on a polar graph via a couple examples. Okay, so let's first take a look at r is equal to sine of 2 theta. Now, the graph of this, if we graphed on r theta axes and then transfer the result to xy axes, we'd see sine 2 theta, the input's going twice as fast through a period of, so a period of 2 pi becomes 2 periods. Looks something like this, roughly. Not exact. All right. So notice that every time we have something from here to here, that's a leaf or a hump going from r value 0 to 0. So here's a leaf or a petal. You have another leaf or petal, another one, another one. Now notice this negative one right here, where r is negative. Let's transfer that in our picture to something positive by moving pi away. By moving pi away, this travels up here, and this travels up here. So really, our graph appears simply as this one when we look at the xy plane, just what we have on top. These petals occurring in our different quadrants. This is quadrant 1, 2, 3, 4. And so in each quadrant, we have something occurring here. 1, 2, 3, and 4. Okay, so we have these 4 petals. Now notice, well, first of all, if we were to look at right here, this is pi, so that's 2 pi, and this is pi, and 0. Notice, if the graph were to continue, because of periodicity, it'd go like this. Notice that the graph is symmetric about the axis pi, x equals pi, or theta equals pi, also 2 pi and 0. That tells us that this graph will be symmetric about the x-axis. Okay, now let's take a look at another symmetry. What about if we take a look at we look at 3 pi halves and pi halves? Notice that the graph here, the corrected graph here, is symmetric about these. So that means that this graph will be symmetric about the y-axis. Okay, now we have a symmetry about the x-axis and the y-axis, and we've seen how we can tell what it is in the corrected r theta graph, taking negatives to positive places just pi away. Now let's take a look at when we at another kind of symmetry, one more. So we have an x-axis symmetry, we have a y-axis symmetry, but we also have symmetry through the origin. Namely, here, if I went straight through the origin to the other side, I have this kind of symmetry, same distance this way as this way across in every single location all the way around. How can I get that in this picture? Well, this picture, it's actually quite simple. It's just a period of pi. In other words, every pi, do I land at the same place? And I do. Every pi, I have a nice period, which is which evenly divides pi naturally. And so because of that, I have symmetry through the origin. So there's 3 types of symmetries we've been discussing. So symmetry across the x-axis, symmetry across the y-axis, and symmetry through the origin. Okay, now what if we changed things up a little bit? So let's look at another example, which, and this example won't have all the symmetries that we had in this one. What if we did sine of 3 theta instead? This graph over here will change. And let's see how it changes. All right. Okay. So when we graph sine of 3 theta, I think a period of 2 pi is split into 3 parts, going 3 times as fast through it. So 2 pi thirds. And then we have 4 pi thirds. And we have a whole period here, a whole period here, a whole period here. Okay. And then naturally, going pi away, let's see what happens here. So pi thirds, if you add pi to pi thirds, you actually get up here. So pi away for this petal is actually right here. So this one is replaced by this over here. It's already there, so we don't have to draw anything new. We can just ignore that. Similarly, this is drawn over here pi away, and this is drawn over here pi away. And so really, our corrected graph, we just erase the negative petals because they're already being overdrawn or redrawn as positive petals. Okay, so that's what our graph looks like right now. Okay, so let's think about what's happening. Notice that if we go pi away from this hump, we get over here where there's nothing, which means that we will not have symmetry through the origin. Also, let's think about these other two symmetries, x-axis and y-axis. Let's start with y-axis. Okay, so let's think about this. So 2 pi thirds, and then we have right here, this is pi thirds, and think about pi halves. So pi halves is actually right exactly in between these. So since it's right in between, we actually do have a nice symmetry about the y-axis. We should. Okay. And all right, so that works. So we're thinking we have nice symmetry about the y-axis. What about the x-axis? So think 0, where's pi? So pi, let's see, so this is 2 pi thirds. And then you go to, right, so each petal length is what? Okay, I want to think for a second. So it's 2 pi thirds, so it's pi thirds. So that's 1/2, and so that's another pi thirds over there. So that must be pi right here, right in the middle. That makes sense. Okay, so because you have, yeah, 3, 1, 2, 3, right. So that's pi in the middle. So right here, notice about pi, I don't seem to have that symmetry about pi. So I'm guessing I don't have x-axis symmetry. And let's see how the graph goes to verify. So between 0 and pi thirds, okay, from 0 to pi thirds, we have a petal right here. Okay, and then we also have a petal from 2 pi thirds to pi. Then we also have a petal from right here, 4 pi thirds to 5 pi thirds, down here. And notice we do have symmetry about the y-axis. That was accurate. We don't have symmetry about the x-axis, and we don't have symmetry about the origin from here to here. So we actually saw all the symmetries on this graph before we even graphed it. We saw the symmetries right over here in this graph, in the corrected graph, after we removed the negative petals to be positive. Thanks for watching.